Good afternoon, Tech Nation. Welcome to Webinar Wednesday. We are excited to have over 400 registered attendees for today's webinar, which is eligible for 0.1 CE credits from the ACI. Let's get started by giving one lucky attendee a I Am Tech Nation t-shirt for answering this trivia question. Gatorade is named after which university mascot? Answer now using the questions feature on your dashboard. While you are answering, I want to remind everyone to mark your calendars for MD Expo Irvine, April 9 to 11, 2017. To receive more information about this and other upcoming MD Expos, including the education lineup, schedule and special events, sign up for our newsletter at mdexposhow.com/Irvine. All right, and the winner of our I Am Tech Nation t-shirt is Walter Serio. Congratulations. The correct answer is the University of Florida. Tech Nation would like to thank our sponsors, Rigel Medical. Rigel Medical is a leading manufacturer of biomedical test equipment, including electrical safety analyzers, vital signs stimulators, infusion pump analyzers, electrosurgical analyzers, and Medibase asset management software. For more information, visit www.rigelmedical.com. Our presenters today are Rebecca Adkins and Jack Barrett for Rigel Medical. Rebecca, you may begin whenever you are ready.
Hi, thank you for having me today. As you said, my name is Rebecca Adkins. I'm from Rigel Medical, and we are doing test equipment. I'm a biomed myself, but I've gone into the sale of test equipment. Today we're going to be covering the ESU testing. On the first slide is just the basics of what we're going to go over. For all of you that haven't seen the new FT10, this is the new one by Covidien. It's going to replace or going in conjunction with the Triad. The faces place is a little bit different, and you can notice some different inputs on it. First, we'll start with some history and theory of the electrosurgical unit. The development of the first electrosurgical unit was by William T. Bovee. Everybody should recognize that name. He was working at Harvard University when he did it, and it was over 90 years ago. The first operation was the removal of a mass from a patient's head performed by Harvey Cushing. The lower-powered hypocator was introduced in the 1940s. So electrosurgery has some different definitions. Basically, it's application of high-frequency electric current to biological tissue. The frequency is used during the surgical procedures because it helps to prevent blood loss, filling the tissue and blood vessels during the cutting of the tissue. And here, as you can see where it falls on the spectrum. You can see where the VHF and the UHF are. There are a couple different types of modes. Monopolar surgery, the current passes through the patient to the electropad, also known as the patient plate. Bipolar surgery, current only passes through the tissue graft between the two electrodes. And you can see that, and all you are very familiar with the little forceps that you do for the bipolar. And that's where the electrical current is passing. The ESU modes are classified different for surgeons than from electrical engineers. Surgeons have all the different classifications. Electrical engineers, we use cut and coag, and that's as biomeds we use that also. The cut mode vaporizes the tissue as the high-frequency current passes through the tissue, and heat vaporization fills the tissue of the surrounding cut. In the cut mode, the electrode touches the tissue and is desiccated. If the electrode is held over, there's an air gap, and this is called RF. In coag, it's basically the same operation as in the cut mode. This is the waveform of the cut, and you can see it voltage over time. This is coagulation of the waveform. You can see it's voltage over time also, but you can see the difference in the two waveforms. Let me back up for a second so you can take a look at the other one. And that was cut, and this is coag. And this is the blend of the two. On the far left-hand side, you can see cut, and on the far right-hand side, you can see coag. And in the middle are the signals of when they are blended together. And this is looking at it on an oscilloscope, and you can see the different waveforms and the trigger edge. This is coag on the waveform on an oscilloscope. The crest factor is the ratio of the RMS and peak voltage. Cut waveforms typically have low crest factors. Coag waveforms typically have high crest factors. And then here's some ranges. The effect. As most of you know, if you did the old type electrosurges, we pretty much just had cut and coag and bipolar. Now we have all sorts of different specialized waveforms. It's kind of like programming your phone. There's so many different waveforms to go through on the front of an electrosurge these days. And they can go by duty cycle or by specialized waveforms. The standards that we use are IEC 60601-2-2. We'll go into a little bit of that now. This standard is for the minimum safety requirements. The manufacturer can always go below and do more than what the minimum is required, but they at least have to do what the minimum is, according to 60601-2-2. For a typical PM, I'm sure all of you guys have done the mini PMs in the past. You do the visual inspection, you know, and you go through the list, electrical safety, the high frequency, the foot pedals, but you always refer to the manufacturer's guidelines. For the Covidien FX, on the service manual, page 513 is where it'll start. And off you'll notice it'll say, check the foot pad. In my shop, it was always a running joke that, you know, the casters are good. So for bipolar, you start out with 100 ohms, and you set the bipolar power to 10. In Covidiens, they were looking for the MA output. So when you go through all the three modes, you want to make sure that the MA output is 316 plus or minus 17. And then for cut, you change the resistance on what you're testing with to 300 ohms, set the cut to 80, and then run through all the modes. The MA should be 516 plus or minus 37. For the coag mode, you set the resistance to 500 and the coag power to 80. You run through all the modes. The MA should be 400 plus or minus 28. Then you repeat the test on monopolar 2 using the handpiece. The rim function on page 517, you use your tester, you set it at 120 ohms. Then you run through a series of tests looking for the green light and then making sure that it will go back to green. I'm sure all of you have done all this quite a few times. You set it at 120, make sure it goes green, slowly increase it, and when the alarm sounds at 135 plus or minus 5 ohms, then you continue through the test. And that'll verify the rim circuit, or otherwise, some people also know it as the patient plate. Then we're going to go through the checking of the monopolar high frequency current. You connect a 200 ohm active accessory through the transformer. Then you connect the monopolar foot switch on monopolar 1. You activate the monopolar foot switch, and the point here is you want to make sure the leakage current should not exceed 100 150 MA for any mode. And if the high frequency exceeds 150 MA, to call the Valleylab service, which is, since we're biomeds, we can also always go in and start fixing it ourselves or checking out the possible problems, which is the rim connector socket for damage. Next, we'll be talking about the rim circuit. Here you see pictured on the far right-hand side, a Megadyne. It's a typical ESU unit. It's a smaller portable one. In the middle, you'll see the screen of what the unitherm looks like when you set it up for the patient plate connector. And on the left, you'll see a decade box. And in the middle, you'll see a patient plate, also known as the rim. Actually, for the patient plates, most of the people have renamed them. Even some of them are trademarked. For example, Bovie, we call it split pad. ConMed, it's ARM circuit. Covidian is the rim circuit. Irby is Nessie, kind of like the Loch Ness Monster. Megadyne is CQM. And Olympus also calls it CQM. For the first triad, you want to go through it to verify the rim circuit. The basic requirements is you need the rim plug, the rim cabling with the white tab on it, and some sort of tester, a decade box or a unitherm. And what you want to do is that when you test it, it must be in the clinical mode, not in the demo mode. And when you do it, you allow 2 seconds between the testing settings for the unit to settle. When you run through the list, it's basically like most other electrosurge units. You set the basic start for the 120 ohms, and you see that the green light illuminates. When you start scrolling up, the unit should alarm between 128 and 142. And this, you go through the series, and you can test all of the rim functions through this way. And then you can see as you go on down, you set it for 30 and see if the green light illuminates. And then you just run through the basic manufacturer's recommendations for this. For on the FT10, it's a little bit different. If you see on the top, you use the rim plug, and then they ask to specify what you need for a decade box or a tester. Then you enter the RF touch screen. So that's a little bit of the difference for the RF10. I'm sorry, the FT10. And then when you go down, and you can go down through the instructions, and they're a little bit different. You're just looking for the decrease, the 50 ohm, and then go down through all the rest of the ZMAG, and then go through the rest of the instructions. Okay, for the power testing, these are what we commonly know as like cut, coag, and bipolar. When you look in the manual, this is what you'll see for the triad for the setup. And this is actually set up for when you use it with a unitherm for the FT10. At the top, you'll see the screen at the FT10. The bottom is just a little layout of what the unitherm will look like on the side. Sorry about that. And for the power testing, the basic process of the generators, regardless, if it's a Covidian, an FX, they're all basically the same. The triad, the monopolar and bipolar, are done in the demo mode. Literature is done in the RF, and the FT10, all power tests are done in the RF mode. This is the ConMed 5000. You can see where the coag is done at 500 ohms, bipolar is done at 350 ohms, and the leakage is less than 100 MA. For the ERB, here's some different settings. You can see where you start at 200 watts, and then you go all the way to 120, and then you go do through the soft coag, the force coag, spray, and go through all the different ranges. Here's the Medtronic. They have several different cuts, and you go through all different cuts, changing the ohms through it, and then you're looking for different outputs. And they're wanting the 10 to 20% for the output. Here's the Megadyne. This is the unit that we had pictured in the very first screen. It's a little bit more basic. You just go through the cuts and the coag with the different ohm settings, and you test it. Here's the FT10. Basically, they're looking for the MA output, and that's for the Covidian units. They're more about the MA and then the load output. So you can go through and you can look at the list, and you set the spray at 120, and then you're looking for 424 M to 575 MA, 570 MA. And then you can go down and you can see the ones below it. So you said it's 10 watts spray, and you're looking for 101 to 181 MA. And you'll go through the list, and it'll be a pass-fail. And here's for cut, monopolar 2. You set it at 300 ohms, and you'll go through the list. For like 300 watts, you'll be wanting to see 865 to 1163 MA. And you'll go through the different tests and be looking for the MA and the tolerance. For the Valleylab mode, you'll be setting it up to 300 on monopolar 2 to 300 ohms. And in the bottom, you'll see a little representation of the FT10. So like for 120 watts on soft coag, you'll be looking for 948 to 1274 MA at 100 ohms when you're setting it up for resistance. And these are just different specifications that the manufacturers specifying that we're going to have to test on. And here's for bipolar. It's a little bit different for a setup. You can see on the picture the representation of what the side of the unitherm will look like. It'll come from both the cuts. They'll both be active probes going into the unit. And you can see on the picture on the FT10 where the leads are connected. And the picture on the right-hand side is the actual output. So you can see, this is where you'll see the MA and be able to record it and see if it's within the tolerances. For bipolar, you're going to have 100 ohms, and you're going to go through this 3 settings. For 95 watts, and you'll look for the MA output. And on the previous screen, you'll be able to see where the MA is. And this will go on regardless of your testing device. For ligature, it must be in the debug mode. And on page 616, you can see how to set up the screen for the debug mode. The should be ligature test, port selection, ligature 1, port 1 test, and then go through, and you'll be able to test it for the ligature on the force triad. On the FT10, you need the RF IED mode. And this will be, you'll go through and you'll see the effect 6, the effect, and the load is 100 ohms. The specification is 1145 to 1538. And this is where you'll see the range again, and then you'll see the output. And once you get the output, that's when you can see if the unit is working properly. And actually, this is a little bit of a setup. And if you guys aren't familiar with it, the Covidian code to get into the mode is 423213. And on the side, you'll see a little bit of the setup of how it is you're using to test it, where the lead's just going straight into the ligature. And if you'll notice, it looks very similar to the bipolar mode. Okay, now we'll go into the high-frequency testing. High frequency is required. I know a lot of people ask, and it is required, and it's for patient safety because, the basic rules, if you don't want to hook your mom to the unit, you don't want to be a biomed. Sorry, that's how I was raised from a long time ago. So when you were looking at patient safety, you know that is a #1 job for being a biomed, and that's why you want to go ahead and test the high frequency. And here it's under the 6060122. And the thing is, for leakage current, the big thing is they should not exceed 50 MA. That's what you're basically looking for. This is a documentation of how when a manufacturer will set up and test for high frequency leakage. And then they'll have different points and it'll represent the body. And you can look and see the 200 ohm resistance measuring the high frequency meter and then different points throughout the table. And this is what the manufacturer will use. And now, if you've been to some schools, you actually see the setup of this. Okay, why test for it besides patient safety? This is just an example. In one study, 31 insurance agency companies, data from 615 claims, then the major claims not directly associated with procedures. The thermal damage was due to unintended patient tissue damage. So there is proof out there that, you know, there is damage for this. What kind of problems? As leakage increases, the density surrounding the patient tissue increases, both of the active electrode and the disturbed electrode. So basically, what's going to happen is when the thermal density increases, the tissue can suffer unnecessary damage. So instead of having the regular surgical site, you'll have more damage beyond the surgical site. And what else can also be affected? Implanted medical devices, cameras, in-room viewing cameras, and ECG monitors. Because you've been into the room where the doctor is complaining that, you know, his monitor is getting some sort of interference, and that could be because of the electrosurge unit. And so, you know, when you go in and you're testing, and that's the way you'll see if the electrical surgical unit is causing the monitor to have any kind of interference. What is tested? Both the active and return electrodes are tested. So what I'm saying here is when you're doing the test, you need to do the patient plate and the active electrode. And here again, it should not exceed 150 milliamps. And here's some devices you can see where you can test with. On the right is our Rigel unit, and on the left are some other types of testing. This is a diagram of what you'll see on the Rigel unit for the Unitherm. And you can notice on the top in the patient plate, the schematic is a little bit different. You'll see the neutral coming in, and then you'll see the test device and the 200 ohm built-in resistors. And this is where you'll go and test for the high frequency. And this is in real life. Also, if you'll notice, there's an oscilloscope port up there for, remember the signals that we were seeing earlier, you can actually go back in and you can see them, so you can prove to yourself and see what the signals look like. But this is what the setup will look like. You can see the active electrode going through the 200 ohm resistors. And this is what the front of the test for the Unitherm will look like. It'll come up and it'll give you instructions on how to set it up. And you'll just press pass, and it'll start testing. And this is when your test will be complete. For the ligature, the system must be in the debug mode. So you can go through and you press it and you get into the debug mode with the code again, 423213. And when you go through and you just go through the steps and you connect, make sure you have the 200 ohm. So if it's basically set up on the Rigel unit already there, but that is what you're looking for, the 200 ohm. And then you can go just through the procedures and check and make sure it does not exceed 130 milliamps. And this is a case where the manufacturers are doing better than the minimum standard. This is a CVS output file from the Rigel Unitherm unit. When you do the testing, this is what you'll see. You'll see what you tested at, how many ohms, and the output, and then if it passed or not. And you'll see this per asset number and per test of any units you're testing. Basically, the utilization, capture, and data of the programs, it's saving you time, and it'll reduce the number of power tests on each output. For closing remarks, thank you for your time. I realize I've rushed through this a little bit maybe, but I was worried about time constraints. But for any questions, feel free to contact me. And here's mine and Jack's email. And now, if possible, we could open it up for questions.
Okay, thank you, Rebecca. The first question we received is, I understand the Unitherm has internal memory. Does it store data from every power, REM/CQM or HF leakage test done?
Yes, it does. Like on the previous slide, it will store them under the asset number that you assign. Some people actually have asset numbers for the hospital, or they use the serial number. And on the previous slide where I showed you all the data output, that's the form that it'll be stored in.
Okay, and following on from that, how does it identify test data for a specific generator?
Oh, I'm sorry, I've answered that already too. It's by the asset number. When you're loading for the program to start the test, it'll ask you for an asset number, and that's where you can use your hospital number or your serial number, and that way it'll be uniquely identified and saved and stored in the Unitherm.
Okay. What other manufacturers do you have automated test sequences for?
We have quite a few. We have Covidian, ConMed, basically all the major manufacturers. But also, the thing is, if you find a manufacturer that's not in our list, you're able to create one from the service manual that the manufacturer gives to you. And it's a pretty easy process. So you can create it and save it, so the next time that you're testing the obscure units, that you can go ahead and have it for next time. And that way it'll save the results and have the testing.
Okay. What is a typical time for a complete PM?
For it's under 30 minutes. For the Triad and FT10, it's about 45 minutes, and that's including the high frequency leakage.
Okay.
And also, if they want to email us at this thing, we do have a little pamphlet that will tell the history and show all the waveforms. And they're little booklets. And it's more of a history and of why we're testing. So it goes a little more in depth of the presentation in the booklets that we can send out to the listeners and viewers.
Okay, thanks for that. For the Unitherm, do you have preset testing configurations for the Valleylab FT-10?
Yes, we do.
How can we obtain these?
If you already have a Unitherm and you do not have that testing, just email Jack or myself, and we can email you the file, and you can easily load it through a USB thumb drive. And if you have any questions, you can call us also, and we can talk you through the steps of uploading it. It's a very easy process through the thumb drive.
Okay, can you hear me?
Yes.
Okay. Can you still hear me, Rebecca?
Yes, yes.
Okay, so would you like me to repeat that last question?
Oh, I'm sorry, I didn't get the, yes.
Okay, so for the Unitherm, do you have preset testing configurations for the Valleylab FT10?
Oh, yeah, I'm sorry. I did answer that.
They're available.
Yes, I'm sorry, I did answer that. I didn't know that you didn't have sound. They can email Jack. Hello?
Hello, yes, we're still here.
Okay, they can email Jack or myself. We'll send them the file, and they can easily upload it through a thumb drive. If they're having issues with it, they can call us and we can talk them through how to upload it. It's a very simple process, and it'll just go in and be with the rest of the list that they have of the tests already on the Unitherm.
Okay. Another question we receive is, how do you get your test data back over to your PC?
The best way is to, when you go to the download mode, there's different download options. The best and easiest way is to download it to a thumb drive in the CBS mode, and then just transfer that thumb drive to your PC.
Okay, thank you. What is the recommended schedule for PM and or test from the Biomed?
Basically, you want to go with manufacturer standards or what your hospital recommends. But manufacturer standards are the basics of everything. I know different hospitals, they can recommend different settings. So you want to start with your manufacturer's recommendations that you find in the service manual first.
Okay. Will it test dental units?
I'm sorry, you're breaking up?
Will it test dental units?
Basically, yes. The unit, it'll test unitherms, hyfracators, electrosurge units, hyfracators. So basically, if it has a cut mode, you'll just go from the manufacturer settings. And this is where I said you can design your own test and go in, and it'll give you a setup for how to set for the cut and the coag, and you'll go through that. Same way with a hyfracator, if you can't find it, you'll just go in, and you can have an automated mode or a regular power test, and you can test it both ways, where you can put in the load that you want and to see the output that you're wanting.
Okay, another question is, what would be some troubleshooting tips for units with HF leakage?
Basically, you want to look at, you want to start with the basics, with the plug, the grounding plug. From there, you want to see what the tolerance is and go from there. Actually, another one you could also test would be actually the cabling itself, and check from there and seeing if the cord is looped around, and creating some sort of inductance. So it'll just start with the basics, and then it'll just go from there, step by step, eliminating things to find out what's causing it. But I would definitely start with the cabling.
Okay, thank you. The ISO standard talks about the same power output from 100 to 1000 ohms. How can we test this?
Jack? I'll defer to him on this one.
I'm sorry, could you repeat the question for me?
Okay, the ISO standard talks about the same power output from 100 to 1000 ohms. How can we test this?
So I think what we're speaking of there is testing a power graph. If you look at an operator manual or a service manual for any generator, they always give you a power curve, power output versus resistance curve. So with the Unitherm, you go into the power graph mode. You can select your starting resistance, 10 ohms or what have you. Select your ending resistance, 1000 ohms. Select the number of test points you want between those two ranges. Hit the start button, and the Unitherm will automatically go through, activate the generator at each resistance point, and generate that power curve for you.
Okay, thank you, Jack. On one of the slides, it mentioned cross-coupling. Could you explain this term?
It's basically when you have the monopolar 1 and the monopolar 2 outputs, and it's basically if one is, you're in use of one and the other one is still having some output, and it'll be a cross-coupling.
Does the Rigel ESU analyzer address ever aspect recommended by Valleylab?
I'm sorry, could you repeat the question? It broke up a second.
Okay. Does the Rigel ESU analyzer address every aspect recommended by Valleylab?
Yes, they do. For our automatic test, it will go through the service manual and it'll step through, like I said, and you'll be able to go through the service manual on the automatic test. If you see something like if they change the modify the testing procedures, you can go in and modify it and make it towards exactly what the service provider, the manufacturers recommend for testing.
Okay, thank you. Does the Unitherm include the external load resistors?
You do not need any external load resistors for any testing with the Unitherm. The 200 ohm resistors are built into the side. Other than that, the resistor load bank will handle anything for the COVID testing.
Okay. Would Rigel come on site to train on their analyzer to multiple techs?
Yes, we do. And being a biomed myself, I know Jack will attest to it. I usually have the habit of bringing cookies with me because I'm a biomed and I know we like to eat. So yes, all you have to do is schedule with us and we can come and do an on-site and show you how the unit works, and you can have hands-on and with your own equipment and see what it'll fit your needs, and go through with your own equipment and see what kind of needs that you do have.
Okay, thank you, Rebecca. Just a message to the attendees, any questions that weren't answered, we will be emailing them to Rebecca and Jack, and they will contact you after the webinar. So thank you, Rebecca and Jack, and thank you again to today's sponsors, Rigel Medical. One lucky attendee will win lunch for their whole department. Details are included in the post-webinar survey, which will appear on your screen shortly. You must complete the survey to obtain your certificate of attendance. If you do not see the survey, email us at webinar@mdpublishing.com.